In this video we're going to be looking at enlargements. This is the first in a series of videos looking at enlargements, so make sure after you've watched this one you follow it up with all of the subsequent videos. Okay, let's kick off things then. So here is a shape. The first thing to notice is that this is a very simple enlargement problem. What I mean by that is there's no axes, no x or y axes, no numbers on this. It's just a shape on a grid and you're being asked to enlarge it by a scale factor 2. Now, the word scale factor means that's how much bigger you're going to make this shape. So if scale factor is 2, the shape is going to get twice as big. If it's a scale factor 3, 3 times as big. And the way we're going to do this one is by looking at some of the lengths on this shape. So I can see that the base of my triangle is 4 units. Now, the scale factor is 2, so when that's doubled it becomes 8. And I know that the base of my new shape then is going to be 8. And I can repeat this process with the other line there. So it's 8 high, scale factor is 2, that means on the new shape that needs to be reflected and it needs to be 16 high. Now notice I stayed well away from the diagonal line. I'm only actually interested in working with the horizontal and the vertical lines. It makes things a lot easier for me. Once I've got the base and the height of this triangle, I can just join it up with a diagonal line to complete the shape, and it's been enlarged by scale factor 2. In this second example, you'll notice that the shape we've got is a little bit trickier. It consists mainly of diagonal lines, and like I said in the previous example, we want to try and stay away from those diagonal lines where possible. So what we're going to do is we need to try and identify some horizontal and some vertical lines that we can then enlarge by the new scale factor in this one, which is 3. So the first thing I'm going to look at is how wide this shape is, all the way from point to point across the shape, and I can see that it's 4 units. So that needs to be reflected in our new shape. The scale factor is now 3, so 3 times bigger than 4 is 12, which means my new shape is going to have a total width of 12 units. I'm going to do the same thing again, but this time for the height of the shape. Notice that the measurements I'm taking are horizontal and vertical and perpendicular to each other. So again, this one is enlarged by a scale factor 3, so in the new shape that reflects as a new length of 12. What I can do then is I know that this shape kind of sits halfway along each of these lines, so that will enable me to draw in my new shape like that and haven't touched any of the diagonal lines. Here's one for you to have a practice on. Pause the video here, hit play when you're ready for the answer. Okay, if you've enlarged this shape correctly by scale factor 2, it should look like that. It doesn't matter if your shape is in a slightly different position to mine, as long as the lengths match up with mine and everything is twice as big as the original. Here's a second one for you to have a practice on. Same deal as before, pause the video, hit play when you're ready to see the solution. Okay, solution to this one then, once you've enlarged this shape by a scale factor of 4, it should look like that. Enormous parallelogram. Okay, thank you for watching this video. As I said, there are a couple more in this series. I would recommend going and having a look at Enlargements 2 next.